Did you know that hurricanes, these massive, swirling storms, rarely have thunder and lightning? It sounds strange, right? We're used to associating big storms with loud claps and bright flashes, but hurricanes are a different beast altogether. And no, they're not some secret government weather experiment. Hurricanes are one of Mother Nature's most powerful and fascinating creations. So, how exactly do these colossal storms form and grow into the giants we see on the news? Let's dive in. It all starts in the warm, tropical waters near the equator. Think of it like baking a cake. You need the right ingredients. The first and most crucial ingredient is warm ocean water, at least 80 degrees Fahrenheit or 26.5 degrees Celsius, extending down at least 150 feet deep. This warm water is the fuel for the hurricane. As it evaporates, it rises, carrying a huge amount of moisture and heat up into the atmosphere. As this warm, moist air rises, it begins to cool down. When it cools, the water vapor condenses back into liquid water droplets, forming massive storm clouds. This process of condensation releases a tremendous amount of energy, known as latent heat. This heat warms the surrounding air, making it lighter and causing it to rise even faster. This creates a continuous cycle, like a chimney, pulling more warm, moist air up from the ocean surface. Now, you might be thinking, okay, so we have rising warm air. What turns it into a spinning hurricane? That's where our planet's rotation comes in. This is called the Coriolis effect. Because the Earth is constantly spinning, it causes moving objects, including air, to be deflected. In the northern hemisphere, this deflection is to the right, and in the southern hemisphere, it's to the left. This is why you'll never see a hurricane form right on the equator. The Coriolis effect is too weak there. So, as our column of rising air gets going, the Coriolis effect gives it a little nudge, a little spin. As more air is sucked into the base of the storm to replace the rising air, it also gets deflected, amplifying the rotation. This is how the storm starts to organize and spin around a calm center, which we call the eye. To become a full-fledged hurricane, the storm needs one more thing: low wind shear. Wind shear is the change in wind speed or direction at different altitudes. If there's high wind shear, it's like trying to build a tower of blocks while someone keeps blowing it over. The strong winds at different levels will tear the developing storm apart. But in a low wind shear environment, the storm can grow vertically, becoming more organized and powerful without being disrupted. The storm officially gets its name once its winds reach 39 miles per hour, at which point it's a tropical storm. When the winds hit 74 miles per hour, congratulations, we have a hurricane. From there, it's categorized from 1 to 5 on the Saffir-Simpson scale based on its wind speed, with category 5 being the most destructive. A hurricane will continue to move across the ocean, feeding on the warm water, until it either moves over cooler water or makes landfall. Once it's cut off from its warm water fuel source, it rapidly loses strength and eventually dissipates, but not before it can leave a significant impact. So, from a patch of warm ocean water to a spinning, powerful giant, the birth of a hurricane is a perfect storm of atmospheric conditions. It's a powerful reminder of the incredible forces at play on our planet. Thanks for watching. If you found this fascinating, be sure to hit that like button and subscribe for more deep dives into the world around us. See you next time.